Hi guys, welcome back. We're going to hit the last part of our review here for Unit 6, and then hopefully you guys be ready for the exam. I'm not going to make a Unit 7 review video since those notes are on YouTube already. You guys can look back at those, review any of those that you choose to review. But again, you guys are ready for this exam. I really think you guys are going to hammer it and really do well on it. Just remember to do your best. Don't go into too much detail, but make sure you're supporting your answers with the necessary information needed for the particular action verbs. The must-haves you should have for your AP exam day set up on your table. Please, by all means, print out those one-page review sheets, but make sure you review them ahead of time so you know what information is on there. Even if you get Post-it notes and stick it on with what material is in that one, so you know which sheet to look at on exam day. The other big one is the one-page review notes page, the one that says ATP at the top in bold letters. I think it's answer the prompt at the top, and then it has all the action verbs as well as some examples on how to answer them. Then down at the bottom, it talks about experimental design, phrases to avoid using on the test, all those different things. I would make sure I have both of those printed out and readily available to me on exam day. Sorry. So with oh, and also don't forget to have your AP exam day checklist. I also in front of you, making sure you have all the required materials you need for the test. With us, it's pretty minimal, but make sure you guys have gone through and check marked everything that's on that list to make sure you have what you need. So when we're looking at Unit 6, it's going to continue on with the renewable forms of energy now. If you remember back to the previous video, we talked about all the non-renewable sources. Now we're getting into the more renewable sources. The first big one is going to be the biomass. And biomass can be used for a lot of different things. We have biomass that's used to heat homes, to cook with, even to power some equipment in less economically developed countries. We don't see that anymore because we don't use steam engines that much anymore. But that's what used to power the steam engines back in the day. With biomass, though, there are some problems with it. Again, you're burning some carbon-containing compound. The trees or the plant life that you're burning have carbon incorporated into them. So anytime you're burning biomass, carbon dioxide emissions are going to be a problem with it. But again, the important thing to remember that if it's a plant matter-based ethanol type of solution, that's going to be a net carbon neutral form of energy. The biomass, like burning trees, though, that carbon dioxide does go up into the atmosphere and increase carbon dioxide levels because the carbon has been stored within the tissues of that tree for years and years and years. So that's carbon dioxide that shouldn't be in the atmosphere. We're releasing that by burning the biomass. So the more trees we cut down and burn, the more carbon dioxide levels we have in the atmosphere. But in addition to that, we also have nitrogen oxide compounds that are released. Remember how nitrogen in the form of nitrates is an essential nutrient for plants. As they absorb that nitrogen in, it's getting trapped within their DNA molecules, within the cells, in the body tissues of the plant. So as we're burning them, those are oxidizing and being released as well. So we do have nitrous oxide compounds. Again, some of those are precursors to acid rain, others are greenhouse gases. In addition, we have particulate matter, that's the smoke. Again, the fine particulate matter, the 2.5, which is going to be released when we're burning this biomass, is a major lung irritant. So the people that are exposed to biomass burning, especially indoors, are going to suffer from respiratory illness and respiratory distress a lot more frequently than people not exposed to it. Because if you have a poorly vented stove or burning over an open pit, that particulate matter that's released is being breathed in, absorbed straight into your bloodstream through your lungs, and it's causing a lot of problems. Not only is it irritating your lungs, but it's also going to get dissolved into your blood in some cases and potentially cause, bloodborne illness type situations where you could get, infections and all those things. In addition, volatile organic compounds, which again are going to help to create that tropospheric ozone. The other big problem with biomass is we're, in a lot of cases in those less economically developed countries, over consuming our fuel wood sources, whether it's for firewood or whether it's for charcoal. We're cutting down trees faster than they can replace themselves naturally. So we experience deforestation. The more deforestation we have, the more the soil profile is affected because now the water flows through those forested ecosystems that erodes and washes into the streams and rivers. So we have a lot of problems tied into burning biomass, but it's a cheap form of energy, so it's widely used in those less economically developed countries. You can go cut trees down for free in most places because they're naturally growing, but we're over harvesting them. Now, ethanol is one that we're turning to in the more economically developed countries because we're needing to find alternatives to the fossil fuel energy, the gasoline that we use. By creating ethanol, we can burn that either as a component of gasoline. We dilute the gasoline down with ethanol to help combust the gasoline and reduce our dependence on fossil fuels. The good news is it's a carbon neutral form of energy because the plant matter that's growing is growing fairly quickly. So it's taking carbon dioxide in from the atmosphere, photosynthesis is occurring, and that carbon that's taken in from the carbon dioxide is being converted into sugar compounds. Those sugars then undergo fermentation. As we cut the plants down and start to ferment them, that creates the sugars that are generated into alcohol or converted into alcohol from the bacteria. That alcohol then is highly combustible. The problem with it is, again, it's a carbon neutral source of energy, but it has an extremely low return on investment as far as energy goes, because we're having to grow those crops to convert into ethanol. Most of the ethanol we make is from corn or sugarcane. The corn and sugarcane requires fertilizer, tractors to be run. A lot of fossil fuel energy is used in the production of it. So a lot of that energy we get out of the ethanol was used to make it in the process. So we have a very, very low energy return on investment. We may only be getting, a positive 2 or 3 unit of energy return on investment. Whereas with fossil fuels, they're super energy dense and it doesn't take a huge quantity of energy to get them out of the ground and refine them. So it's a much higher return on investment. So we're having to use a lot of energy to produce the ethanol. So even though it's much more environmentally friendly from a pollution standpoint, from a carbon standpoint, all those other things, the energy return on investment is so low that it doesn't make it a great alternative fuel source. Other forms, we have solar. Again, you guys should know how solar energy is used to produce electricity. The sunlight comes down, the light energy hits that photovoltaic cell, the PV cell. That's going to release electrons from that silicone wafer, and those electrons then flow through a circuit. That generates an electric current, which then powers our electrical appliances. It's a great form of electricity generation because, again, it's completely, it's a clean source of energy. Again, don't ever say it's a clean source of energy on the AP exam. Elaborate what you mean by that. It's a non-atmospheric polluting form of energy. There is going to be pollution in the life cycle of that photovoltaic cell, though. We have to mine for the silicone and purify it. It has to be ultra pure silicone in order to be able to be used in the production of the photovoltaics. So we have to mine for that silicone. We have to process it and create the panels. So pollution is made along the way. And then once the cell reaches its life expectancy after 25 or 30 years, now that cell has to be disposed of. We put it in a landfill that has that potential for even more pollution. The main limiting factor with solar energy is the cost associated with it. And not only the cost associated with it, but you need massive amounts of space to provide enough solar panels to generate enough electricity to power, the devices we use. One of the good alternatives for that amount of free space is putting these panels on people's roofs. The more roofs we have with panels on them, the less land space has to be taken up. We've already put buildings in place. Why not put those solar panels on each of the roofs? That creates little microgrids. If all of those start to link together, now we have enough energy to power a small city. So those would be great alternatives that you guys could use, shifting from fossil fuel type of electricity generation to now switching to more of a renewable form in the form of solar panels. There's two different types of solar energy creation. There's active solar and passive solar. The big difference between it, active requires the use of machinery. So we have to do something to capture that energy and store it for our use later. So, and a lot of times they'll heat liquids up. That warmed liquid then will be able to be stored, pumped through a building, and then used to heat a house or to generate steam, etc. Passive solar systems, they don't have the ability to be stored, but they don't use any mechanical energy, no electrical equipment, nothing. That's the sunlight coming in through your house. So passive solar systems would be making sure your windows are on the north and south side facing of the house. That way it maximizes the amount of sunlight coming in. We want to make sure that we're using the correct colors of building materials, lighter colors in warmer climates, darker colors in colder climates to maximize the amount of sun energy being absorbed. They do have all solar systems have low environmental impact, but they are really, really expensive. The larger the scale you're using, the more environmental impact we have. As we start turning towards these solar farms, that's when we're starting to see more ecosystem destruction from it. But we do have the ability to put them on rooftops, which would minimize that impact. The solar thermal power plants that we talked about in class, remember the one with the big mirrors that concentrates on the big salt ball on top of the pole. It melts the sodium chloride. That sodium chloride then stays warm for a long period of time to generate a lot of steam energy, which can then turn turbines. Those are going to be the ones that do have impact on the ecosystems. They're used mainly in the deserts because you need a lot of sunlight, very little rainfall, and you need wide open flat spaces. We don't think about damage to the desert ecosystems being a bad thing, but when you think about topsoil production, topsoil doesn't get produced in deserts very quickly because there's really not that much organic material, pardon me, not that much organic material, and also the rate of decomposition is really slow because there's not much moisture for the bacteria to use. So when we damage those ecosystems in the desert, recovery from that damage takes thousands of years to happen. So the solar systems that we're putting in the deserts, that does have that potential for environmental damage. Now, with hydroelectric, a lot of people associate all dams with being able to produce electricity. The majority of dams in the world are there for flood prevention. So they're there to hold water back and slowly release it in times of heavy rainfall. That way it regulates stream flows. Dams, according to College Board, are almost always a negative to the environment. So if they're looking for positive changes we can make, try to avoid using dams as your positive, because there's extensive ecosystem changing that happens. It's not necessarily it's destroying one ecosystem, but it's replacing it with a different one. So it causes drastic changes to habitat. If it happens to be an endemic species that's getting flooded out, that endemic species can then go extinct as a result. And again, endemic species are the ones found in only one specific area. So there is no air pollution or waste with them, but the construction is extremely expensive. It's going to take a ton of money to install those dams with it. And also, it's going to drastically change the environmental conditions in the area. You took a terrestrial habitat and now you're flooding it, creating an aquatic habitat. But the way they work, if it's a hydroelectric dam, the dam is here that stores the water behind it. That's basically storing potential energy. As the water is released through the dam, that potential energy is turned into kinetic as the water begins to flow through. In the pipes that the water is flowing through, they'll put the turbines. The turbines spin, which turn the generators, which creates the electric current. So it is a clean source of energy, a non-polluting form of energy, but there's a lot of environmental damage associated with them. Again, you have flooding that's associated behind the dam, which is going to alter ecosystems and change them from terrestrial to aquatic. It's going to displace terrestrial species. And then also, when we first flood out the dam, all that organic material now is buried under hundreds of feet of water. So that organic material starts to anaerobically decompose, which releases methane up into the atmosphere. But the goods of dams are they provide recreation, they provide stable sources for drinking water, they provide flood prevention, all those different things. Geothermal is one that we don't use very much in America because it has very specific criteria that has to be met to use it. You need to have the magma close to the surface. So the best place for this is in Iceland because, again, it has that convergent boundary. Remember how we talked about convergent boundaries? As the plates pull apart, it kind of creates that depression in the ground. That depression in the ground, that valley, makes the magma really close to the surface. Iceland is right through that mid-Atlantic ridge plate separation, the divergent boundary that's occurring out in the middle of the Atlantic Ocean. That plate continues up, and the island of Iceland is contained within that divergent boundary. So as the plates are separating apart, now the plates are becoming thinner, the magma is closer to the surface. We can harness the heat from that magma to generate steam, to spin the turbine, to turn the generator, to create the electric current. But it's extremely, extremely expensive, and it only works when it's in those types of situations. So if you don't have hot springs around you, or you're in a country that's really volcanically active, you're probably not going to be able to utilize geothermal energy. One of the big problems with geothermal, again, we learned that volcanoes are a major source of sulfur dioxide. Most of the sulfur in the sulfur cycle, the largest reservoir of sulfur in the sulfur cycle is underground rock. As that underground rock melts, the sulfur dioxide is released. So if we're drilling into the areas with that magma, we're going to hit pockets of sulfur dioxide, which go up into the atmosphere. Sulfur dioxide, again, primary pollutant, it converts into the secondary form, which is sulfur trioxide, which then converts into the secondary form of sulfuric acid. That's what creates our acid rain for us. Okay, then we have wind power also. Wind power is one that I think that we're going to see expanding greatly. I think solar and wind power are the two that are going to expand greatly over the next 15 years or so. You have very little land that's actually used for it. You might have the footprint of your house be the base of the windmill. So large farms can install these wind turbines on their property without really impacting their crops as much. Yeah, they have to change because they have to go in between the windmills to harvest their crops. Or if they're grazing cattle, they have to allow the cattle to graze through the windmills. But it's not as majorly disruptive. They can still farm the land and get benefit from that, produce food for the population. They can bring in an income from selling off the food that they're producing. And they can also generate free, cheap electricity for us that's clean and environmentally friendly. But the drawbacks are the wind turbines are super expensive to install. So the farmer's not going to incur that cost. The company that owns the windmill is going to incur that cost. But when you talk about and compare the cost of a wind turbine and the cost of a power plant, they're fairly comparable now. The cost of the turbines is coming way down, and the output of the turbine is also increasing exponentially as well. So we are installing larger and larger turbines, which is producing even more electricity. Again, they only make sense in places that there's no tornadoes or hurricanes, and they have to be usually installed high on hillsides or high in mountain ranges because that's where the more forceful winds are blowing. Upper atmospheric winds are a lot stronger and a lot more steady and constant. The other place that's good for them is in the Midwest, out in the plain states, because the flat land, there's nothing to inhibit the wind blowing across. Another good spot for windmills. But we wouldn't want to put them near, the southern states coasts because of the hurricanes that come through. That wouldn't be a great choice because we'd be constantly repairing and replacing them. The problem with putting them on mountain ranges is birds are flying as they're migrating. And if the birds fly through the path of that windmill, there's hundreds of thousands of birds that get hit with the blades every year and killed. So they do kill a lot of birds and disrupt migration routes. In addition, they can kill bats, which bats are extremely important for insect control. They're really disrupting migration routes of a lot of flying organisms. Now, the other thing I want to talk about is energy conservation. And energy conservation is how we can start mitigating the effects uh, of consumption of fossil fuels. We're putting so many pollutants up into the atmosphere and into the water from burning fossil fuels that energy conservation is key to it. So what we can do to save energy, the first 4 bullets here are at the individual level. What we can do within our house. We have to know there's individual things we can do that conserve energy. Then there's the larger scale state and country level type of energy conservation practices. So at our individual level, we can adjust our thermostat. Simply turning it down a couple of degrees in the winter and turning it up a couple of degrees in the summer months helps to save a lot of energy. If my thermostat was normally set on 70 degrees, now instead I'm going to set it at 68 degrees in the winter. That way it's at a colder temperature, my furnace isn't going to be running as much. That's less natural gas that I'm burning to heat my home. And same thing in the summertime. If my thermostat is usually set at 70 degrees, I'm going to set it at 73 or 74 degrees. Now my air conditioner doesn't run as much, less electricity used means less fossil fuel energy to burn. And that's an important thing. Always link electricity to using fossil fuels. That's how we generate it. A lot of our electricity generation in America is done by burning coal. So less electricity usage means less coal burnt. Less coal burnt means less sulfur compounds going up into the atmosphere. Less sulfur equals less acid precipitation. It's going to help to, again, make those connections and spiral back through all the content we've learned. The other thing we can do is something you don't link to energy usage, but conserving water. You take it for granted that when you turn the water faucet on, water comes out, but it takes electricity to power that water. Not in your house, but at the municipal level. The pumping stations have to pump that water and pressurize the lines. By pressurizing the lines, that allows it to flow into your house. So your electricity bill isn't going up when you turn the water on. However, it is still using electricity in the process. In addition, if you're using hot water, the hot water has to be heated in your home. So by conserving water, taking shorter showers, doing more efficient laundry methods, all those different things, you're going to save a lot of electricity by doing that. And then a new one that's picking up more and more is using something called xeriscaping. And xeriscaping, Xeriscaping, I believe is how you spell it. You can Google it though. But using xeriscaping is landscaping that uses little to no water, replacing grass with rocks and water thrifty plants like succulents and smaller flowers that don't consume as much water as grass does. Now we don't have to water our lawns to keep a beautiful looking yard. Xeriscaping, you can get xeriscaping done that looks amazing, but uses only a minimal amount of water to keep everything alive. Now, on the larger scale, at the state and country level, we want to improve our fuel economy. There's something called the CAFE standards, CAFE standards, corporate average fuel economy standards. That's how much gas mileage per gallon you have to be able to get using that vehicle. If we put mandates and restrictions on auto manufacturers and tell them all new vehicles made after 2020 have to meet criteria levels for fuel efficiency, then that's going to help us use less fossil fuel energy. So say that right now the corporate average fuel economy standard is at 25 miles per gallon. If we up that to 30 or 35 miles per gallon, now the auto manufacturers have to make a more efficient engine. More efficiency means less gasoline burned. Less gasoline burned means there's less carbon dioxide, less particulate matter, nitrous oxide compounds going into the atmosphere. In addition, we would have a reduction in the amount of tropospheric ozone created, since burning gasoline is one of the big precursors to creating that tropospheric smog. The other thing, this is a tough one. Battery electric vehicles and hybrids, they don't necessarily conserve energy, because even though we're not burning gasoline, we're still using fossil fuel energy to charge the batteries. So we would want to include in an answer with that. If we use battery electric vehicles and hybrids, we want to make sure that we're charging the batteries with a renewable form of energy, such as solar power, wind power, geothermal. Geothermal, I probably would stay away from, since we're not really using that in America. I would turn to making sure it's charged and the electricity needed is provided either through solar panels or wind power. That's going to help us change again from fossil fuel energy to a more renewable, cleaner burning form of energy, or cleaner form of energy. Shifting to public transportation. Again, even though a bus is going to get considerably lower fuel economy, now you have to share that fuel economy though with the 50 or 60 people that are on the bus. When you do that, that's so much greater of a return. You get so much more of a energy per unit of person than you would driving in an individual car. If each of those 50 people would drive their own vehicle, even though their vehicles are getting more fuel efficiency than what the bus is, it's 50 cars on the road. So that amount of efficiency is dissipated. Public transportation is always a great way. And we can incentivize the use of it by offering it for free through subsidies. Government, state and federal government could offer subsidies to the public transportation. And that's another big thing. When you're talking on the AP exam about legislation, make sure you're passing it at the state level or the federal level. Don't say local communities can incentivize using public transportation. That's really hard for local communities to do. So they could offer subsidies and free transportation through tax money for public transportation, but it's easier if you link it at the state or federal level. Most of the time, the money that the local municipalities gets comes from the state and federal government anyway. So again, public transportation, great way to improve efficiency. And then the other one is green building design. The green building design is things like using living roofs, passive solar energy design, roof overhangs, things like that. Things that make the buildings more efficient. The more efficient a building is, the less energy that has to go in towards heating and cooling them. So all those are ways to improve energy conservation practices. And that's it as far as our review, guys. I really hope that you guys learned a lot this year in class. And I hope that you guys really, really try your hardest on the AP exam. I know you will, and I know that the grades are going to come as a result of that. I really think this is going to be one of our most successful years in spite of everything that's gone on. I hope that you guys, just put your nose up to coronavirus and say, hey, I'm not letting this affect my AP exam. I'm going to go out there and get those 3 college credits and that $100 from NIMSY. So if you guys have any questions leading up to the exam, please send an email out, ask any questions you guys have. I'm here to help you and review with you.